17 of ETC 779. In this class, I will take your doubt after the class, please. In this particular lecture, we are going to cover sensitivity analysis. What we are going to see in this is what happens if a particular variable is changed, whether the decision that I had taken earlier still remains good or has it changed. If you remember, in all our previous discussions, we had assumed that all the variables under consideration were constant, but in real life situation it may not be that so. When I say variables were kept constant, means I had assumed that interest rate is going to be same throughout the period of the equipment or throughout the service life of the equipment. Salvage value, whatever I had assumed, is going to be constant. Whatever incoming values I had taken in my cash flow diagram, I had assumed that to be constant. Similarly, whatever outgoings were there in my cash flow diagram, I had assumed them to be constant. In real life situation, what you find is that these values may change. After all, these are your estimates, correct? These estimates you have made keeping some things in your mind, and all the time the estimates may not be correct. As far as initial cost is concerned, your estimate is right because you are dealing at time t is equal to 0. But as far as incomings are concerned, as far as outgoings are concerned, as far as salvage value is concerned, as far as the age of the equipment is concerned, as far as the interest rate is concerned, these are all your estimates. Now, estimates may go wrong also. So, what we are interested in this particular lecture is, suppose my estimate goes here and there by, let us say, plus minus 10% or plus minus 20%, will my decision change or will it still be the same decision? So, that is the purpose of conducting sensitivity analysis. Now, there are different types of sensitivity analysis we will see. In the simplest example, we can make changes in single variable at a time. Now, what are the variables we are concerned with? The incomes, the outgoings, the interest rate, the salvage value, the age, all these can change. And in the simplest example, we will assume that each of the variable is going to be changed one at a time. Then in another type of sensitivity analysis, I can take two variables changes at a time. Then in more complex problems, you will find that all the variables are changing simultaneously. Now, we will study the impact of these changes on our decision. In whatever problem we have discussed before this class, we were arriving at a single decision, either to accept the proposal or to reject the proposal. This is what we had done till now, based on a fixed value of certain variables. Now, I am interested in knowing, if I change this variable from this value to this value, is my original decision still valid or will it change? So, that is the purpose of conducting sensitivity analysis. I hope the objective of performing sensitivity analysis is clear to you. So, in this particular class, we are going to see what is sensitivity analysis, what are its advantages, what are its limitations, what are the different types of sensitivity analysis, what are the ways in which you produce the result of sensitivity analysis. So, these are the focus of our today's lecture. Now, if you see this slide, it is very clear that in all our preceding discussions, we had arrived at a particular decision. What kind of decision? Either acceptance of a proposal or rejection of a proposal, or else selection of one alternative out of several alternatives possible. Now, these were done assuming that the estimates for different variables. What are the variables? Initial cost, receipts, disbursements. Disbursements is nothing but outgoings. Receipts is nothing but incomings. Interest rate, life of the assets, salvage value. We had assumed all these variables to be constant. Clear? But in this particular case, we are going to change the variables, sometimes one by one, sometimes two variables together, sometimes more than two variables together. You will find that, as I was discussing just now, in real life situation it is very difficult to find certain things which go exactly as per your plan, as per your estimate. For example, you might have estimated that by operating this equipment you are going to earn 100,000 every year, but this 100,000 value is your estimate. 100,000 could become 90,000, it could become 120,000, both possibilities exist. Very rarely you will find that whatever your estimated value was there, that is going to be actual in practice. It is very rare combination. Whatever I plan, exactly as per that it is going to happen, very rare situation. So, more or less in real life situation you will find that the actual values will be slightly different from your estimate. But if this is so, I am interested in knowing, is it going to change my earlier decision? Suppose based on a set of values of different variables, I say accept this proposal. Now, tomorrow those values are changing. So, you want to see right at the beginning, will it change my decision? So, that is the basic objective of conducting sensitivity analysis. For example, take another variable, life of the asset. You might have estimated the life to be 6 years, but the equipment or the asset may last for 8 years, or it may last only for 5 years. Now, the result could be different, the decision could be different, because your variable value has changed from originally estimated 6 to maybe 8 or to maybe 5. So, you want to know whether by changing this variable my decision still remains the same or not. Now, we may like to know what will happen to the net present worth associated with a particular investment when some variables like incomings or outgoings vary from its expected value. Now, I will make it very clear at this point of time that sensitivity analysis can be performed for any of the method that we have studied till now. For example, you can apply it for net present worth calculation, you can apply it for annual cost calculation, you can apply it for rate of return calculation. But in whatever example you will see, I have taken net present worth computation because that is most commonly used as far as sensitivity analysis is concerned. So, if I have to summarize the objective of sensitivity analysis, I can say that it is nothing but the study of impact of change in the value of variables on the economic decision in a particular situation. So, the basic objective is what is going to happen to my decision in case some variable or most of the variables have changed in values. Has it changed my decision or is my original decision still valid? That is the main objective of performing sensitivity analysis. In a sense, if you try to say it in other words, it tries to answer what if. So, sometimes it is also referred to as what if analysis. What happens if my salvage value increases from 20,000 to 40,000? Or what happens if my salvage value decreases from 20,000 to 10,000? What happens if the interest rate goes beyond 10%? What happens when the interest rate comes down to 10%? What happens if the incomings from maybe 100,000 now changes its value to 150,000? So, basically in sensitivity analysis we are trying to address what if questions, right, and that is why sometimes sensitivity analysis is also known as what if analysis. So, this is also one of the ways of conducting what if analysis. Now, the changes, it could be increase or decrease in the assumed values. The changes in the variable values may or may not lead to the reversal of our earlier decision. Sometimes you will find that whatever decision you had taken based on the constant values of variables still hold good if you change the variables, but sometimes it may not be the case. Now, I have to identify the sensitive variable vis-a-vis the less sensitive variables. So, how do I decide on that? Suppose even a slight change in one variable changes my original decision. I say that this variable is quite sensitive. Is it clear to you? Suppose interest rate from current 10%, I change it to 9%, and I find that my decision has reversed. Initially, I must have recommended acceptance for this proposal. Now, the result is rejection of that proposal. So, what you find? Even by slight change of interest rate 1%, my decision has changed. So, we call such variables as highly sensitive variables. Now, if you take the opposite case, even if you change the variables by 50% or 100%, still there is no change in your decision. So, we call those variables as insensitive variables. Is it clear? Say for example, you have estimated the salvage value for a particular equipment as 100,000, but in real situation you are getting a salvage value of only 50,000. So, your original estimate has changed to minus 50%. Now, suppose even this large decrease does not result in your reversal of decision, we say that this is a insensitive variable. So, do you understand what is meant by highly sensitive variable and what is meant by insensitive variable? I will repeat it once again. Even if there is a slight change in one variable which is resulting in change of decision, we call that variable as highly sensitive variable. Whereas, even if there is a large change in one variable and still there is no reversal of decision, we say that this variable is insensitive. So, what is the use of this sensitive variable, insensitive variable, less sensitive variable? What is its management implication? If you find that variable x and y are highly sensitive, that means we have to be extra careful in estimating their values, because our all decision depends on this estimate. So, we have to be very careful while estimating these highly sensitive variables. Whereas, if you find that some variable is highly insensitive, in such cases for those variables you can relax a bit, you need not estimate too rigorously. Whereas, for sensitive variable sometimes you may have to engage certain consultants also. These consultants are experts in estimating these variable values. So, this is the management implication of highly sensitive variables, less sensitive variables and insensitive variables. So, what we find is that sensitivity analysis is also aimed at identifying the sensitivity of a particular variable. So, let us say out of 6 variables under consideration, we are trying to identify which variable is highly sensitive, which variable is less sensitive and which variable is insensitive. So, that is also one of the aims of conducting sensitivity analysis. Now, if you try to go into the mathematical aspect, sensitivity analysis falls in non-probabilistic technique. It is not a probabilistic technique, it is non-probabilistic technique, since it does not consider the probability of occurrence associated with the variation in variables. Here we are not concerned with what is the probability that my salvage value will come down by 50%. What is the probability that my interest rate will go up from 10% to let us say 12%. We are not interested in finding the probability values. That part in which you take probability values into account comes under risk analysis, which we will study separately. In sensitivity analysis, we are just concerned about the changes and not the probability associated with different changes. So, that is why it is said that it is a non-probabilistic approach. Is it clear to you? Now, coming to the different types of sensitivity analysis, I have tried to make it in a form of a diagram. If you see this diagram, if you look at this diagram, you will find that sensitivity analysis can broadly be classified into 2 main categories. The sensitivity analysis being performed for single alternative, and second category would be for more than one alternative. Now, in single alternative we have different cases. In single alternative, we can change one variable at a time, we can change two variables at a time, and we have an option of changing more than two variables at a time. So, as you can see from this slide, sensitivity analysis can be performed mainly for two types of problems. One involving single alternative, second involving more than one alternative. In single alternative, we have three cases. Case 1, change in one variable at a time. Case 2, change in two variables at a time. Case 3, change in more than two variables at a time. Now, when you come to more than one alternative, here again we have got these three cases: change in one variable at a time, change in change in two variables at a time, and finally change in more than two variables at a time. Now, you will find that it is customary to show the results of sensitivity analysis in the form of different diagrams. For example, we show the result in a spider web diagram form, in family of curves form, or else in scenario analysis form. These are different ways to produce the sensitivity analysis results. When we are performing single variable changes, we show it in the form of a spider web diagram. I will show you, I will give you some diagrams which will clearly show you what I mean by spider web diagram. When I am performing sensitivity analysis taking two variables at a time, I usually show it using family of curves method or isoquants. And when I am taking more than two variables at a time, I usually put my result in the form of a scenario analysis. All these three cases we are going to study one by one. So, this particular slide is giving you the explanation of this previous slide, and whatever we have discussed, this is written over here. For example, in single alternative, the most simplest case is change in one variable at a time. The next difficult one is two variables changes at a time, and lastly we can have more than two variables changes for a single alternative. Now, whatever cases we have discussed, these cases are applicable when we have got more than one alternative with us. So, that type of sensitivity analysis also is possible when we are given more than one alternative. All three cases are possible. Of course, these are slightly complicated, and we will try to understand it through some simple examples. Now, as I told you slightly in the beginning, sensitivity analysis can be performed using all the methods that we have studied for evaluation of alternatives. For example, you can use net present worth, you can use annual cost method, you can use rate of return method. All these methods are possible, and you can incorporate them for sensitivity analysis. Now, one more thing, this sensitivity analysis can be performed on pre-tax cash flow diagram or post-tax cash flow diagram. If you are given the information on taxes, depreciation, etc., it is better to use sensitivity analysis using post-tax cash flow diagram. If such informations are not available to you, you conduct the sensitivity analysis on pre-tax cash flow diagram. Now, we will take one simple example. Through this, whatever concepts we have learned just now, we will try to illustrate. For this particular illustration, you can note it down. I have assumed that a new piece of equipment has been acquired for rupees 500,000. So, the acquisition cost is rupees 500,000. The incomings, that is the receipt, we are getting as rupees 100,000 every year for next 10 years. Receipt is 100,000 every year for next 10 years. Outgoings, which is nothing but disbursement, this is rupees 5,000 every year for next 10 years. Salvage value is rupees 50,000. Interest rate is 12%. Service life is 10 years. Now, till here there is no difference between whatever we have studied earlier and what we are going to study now. This type of problem we have already solved. Can you find it out whether you should go for this particular alternative or no? This is very simply done by calculating the net present worth. If you find that the net present worth for this alternative is positive, you should go for this particular asset, otherwise no. So, step 1 is using whatever knowledge we have till date, we have to find our decision whether to accept this alternative or whether to reject this alternative. So, please find out the net present worth and tell me the answer whether you would like to go for this acquisition of asset or no. To help you understand this more clearly, I will give you the flow chart, or rather the cash flow diagram for this particular problem. I will just try to draw it. Asset, its acquisition cost is 500,000 at time t is equal to 0. Now, incomings, which I saw it on plus side, is 100,000 every year for next 10 years. So, this is year 1, 2, 3, so on, year 10. This is 100,000 every year for next 10 years. Now, my outgoings are rupees 5,000. So, I saw it in negative side, this is 5,000 every year for next 10 years. The salvage value, which you will realize at the end of year 10, is 50,000. Interest rate is 12%. Now, what I have to do is, I have to calculate the net present worth, which will be given by minus 500,000 plus 100,000 P given A at 12% interest rate for 10 years minus 5,000 P given A 12% for a period 10, and now I have to take salvage value also, which will be plus 50,000 P given F at an interest rate of 12% for a period 10. I am getting this value as 52869.4. So, basically my net present worth is coming to be positive. So, what would be the decision? Technology class, net present worth is positive. What is the decision? Very good. Now, the real work of sensitivity analysis will start. Till here, there is nothing new. All of us know, because we have been exposed to this kind of problem from last so many days. Now, let us assume that the estimate of incoming value goes wrong. Incoming value is 100,000 per year, it goes wrong, and now the actual value, let us say it is 90,000 per year. So, what will happen to your decision? I will recalculate my net present worth with this value as 90,000. So, what is happening? The incoming value has decreased by about 10%. Now, let us see what happens to my decision. I will recalculate my net present worth, and it will be calculated like this: net present worth is equal to minus 500,000 plus 90,000 P given A 12%, 10 years, minus 5,000 P given A 12%, period is 10, plus 50,000 P given F 12% and 10. I am getting a net present worth value equal to minus 3,632.80. Now, what will happen to my decision? It will be reversed. Now, you will not recommend this acquisition of asset. You will say reject it. So, in this problem, what we have seen? We have kept all the variables values same, and we have changed only one variable. The variable which is changed is incoming, and it has been changed from 100,000 per year to 90,000 per year. And I find that my decision has been reversed. Now, similar type of analysis I will perform on other variables also, but one at a time. So, I may change my interest rate from 12% to maybe 10% or maybe 14%, and I will see whether my decision has changed or not. I will change my salvage value from current estimate of 50,000 to maybe 100,000 to maybe 25,000, and I will see whether my decision has changed or still remains the same. Likewise, I will change my outgoing values and I will see whether my decision still holds good or has it changed. Now, the result of all these analysis for changes in variables one at a time is shown on the spider web diagram. Now, I will show you how this spider web diagram looks like. On one axis, we are writing net present worth NPW, maybe on y axis. Let us say this is 0, these are some plus values, these are some minus values, right. Suppose the receipt diagram is something like this. This spider web diagram can be represented in two ways. One in which you can use the absolute values, other you can use the percentage values. For example, when I changed my incomings, I found that at 100,000 my net present worth was rupees 52,869. At 90,000 it has come down to minus 3,632. So, these 2 points I can plot, on which on one axis I am having absolute values of net present worth, and on horizontal axis I am having the absolute values of incomings. For example, I will show you, say for example, this, let us say it is 90,000, and let us say this value is 100,000. On x axis I have got incomings, on y axis I have got net present worth. So, at 90,000 what you find is that this value is minus 3632.8. At 100,000 what you find is that this is about 52,869. So, this is one way of showing the result of your sensitivity analysis. Now, similar diagram you will do it for other variables. For example, there could be a line like this for some variable x, or there could be a line like this. So, this is the example of a spider web diagram in which I am using the absolute values of different variables versus net present worth. Now, there could be another way of plotting the spider web diagram, which will have a representation like this. On y axis I have net present worth again with 0 value here, plus value here, minus here, and then on x axis I have percent deviation from estimated values. Now, in this representation, I am trying to use the percentage deviation value. For example, I can get a diagram like this. I can get a diagram like this. Let us say this is 0 deviation. That means whatever my estimate was there originally, if there is no change, I must be getting a net present worth in positive as far as this example is concerned. Now, what happens if my original variable has deviated by minus 10% or plus 10% or plus 20% or minus 20%, minus 30%. So, this is another way of showing the spider web diagram in which we are changing single variable at a time. Now, this spider web diagram itself will tell you which variable is sensitive and which variable is insensitive. If you find that the slope is very steep, that means even if there is a slight change, a slight percentage deviation, the decision is going to change. So, steeper the slope, the sensitive the variable is. If the slope is almost flat, the variable is as good as insensitive. If the slope is very steep, the variable is highly sensitive. So, this is the advantage of showing the results of single variable changes on a spider web diagram. It immediately tells you which variable is highly sensitive, which variable is less sensitive, and which variable is insensitive. For this problem, you can complete the remaining part. For example, I have shown you the changes for incomings alone. You can work it out, the changes in interest rate, the impact of change in life of the equipment, the impact of change in salvage value of the equipment, and finally the impact of change in the outgoings. All these variables, you put it on a single diagram and see for yourself which variable is highly sensitive, which variable is less sensitive, and which variable is insensitive. So, this is the discussion on the simplest problem which you face in sensitivity analysis. That is, we have seen single alternative, single variable changes. Now, we will see the second case of the single alternative, which is change of two variables at a time. In real life situation, you find that the change in one variable may affect the change in other. For example, if the life of the equipment comes down, your salvage value may go up. If the life of equipment increases, your salvage value may come down. So, as far as real life situation is concerned, single variable sensitivity has got limited utility. So, we will show you how to conduct sensitivity analysis in which two variables are changed together. We will also tell you how to show the changes in two variables together, what kind of diagram we use for its representation. That is, what kind of diagrams we show on which we show the results of sensitivity analysis involving changes in two variables. For that, we will take the same problem and we will study the changes in which two variables are involved together. For example, let us consider receipts and life together. So, we are going to study two parameter or two variables sensitivity analysis now. Two variables sensitivity analysis. Let us take incomings or receipts, whatever you call, and life, these two variables together. So, there are two approaches here. In one approach, what we do is, out of the two variables, at the beginning we keep one variable fixed and change the other variable. For example, let us fix the life. Current estimate of life is 10 years. So, let us fix the life at 10 years. Now, go on changing the value of incomings. I draw a diagram like this. In which here I write present worth or net present worth, whatever you say, and here I write receipts or incomings. So, on x axis I have got incomings, on y axis I have got present worth or net present worth. Now, I fix the life, let us say at 10 years. Let us say life n is 10 years and I go on changing the value of incomings. I may get a line like this. This is at n is equal to 10. That means, I have assumed life of 10 years as fixed, and then I am going on changing my incoming value from 100,000 to maybe 90,000 to 80,000 to 120,000 to 130,000. I may get a line like this. Now, I again change the value of n from maybe n is equal to 10 to n is equal to 8 or n is equal to 7. So, let us put n is equal to 7 and again go on changing the value of incomings. I may get a curve like this or a line like this. Now, again maybe I will go a bit higher, I will take some value of n as let us say 12 years, and I may get a line like this. So, this type of representation of showing two variables changes together is known as family of curves. So, this type of diagram we call family of curves. Now, as an exercise, you can take another two set of variables, maybe life and salvage value. You can fix the salvage value at a time and go on changing the life. Once you have obtained a line, again change the salvage value and then go on changing the life. So that again will give you the family of curves involving life and salvage value. So this is one way of showing the changes in two variables at a time. Now I will show you another way of showing the results of sensitivity analysis involving two variables changes at a time, and that is known as isoquants. So I will give you an example of isoquants. You can plot it on your own for this particular example. This is another way of showing the results of sensitivity analysis involving two variables changes at a time. Again, as in previous case, let's take receipts or incomings versus life. Incomings is one variable and life is another variable. Now in this particular method, I have to find out a set of points, set of coordinates involving different values of incomings and life at which my net present worth is 0. So if you represent incomings with, let's say, I and life with n, so basically I am interested in finding the values of I1 n1, I2 n2, I3 n3 and so on, such that my net present worth at these very points are 0. So that when I join these two all set of points, I may get a curve like this. Here on x axis I have got incomings, on y axis I have got life in years maybe. So what is happening? My xy plane is getting divided into two parts. One this side of this curve, another one is this side of this curve. And this curve or line itself is known as indifference line. This is known as indifference line. What is the meaning of indifference line? On this particular line, no matter wherever you go, you are unbiased, you are indecisive, you are neither for the proposal nor against the proposal. So this is the meaning of indifference line, neither for the proposal nor against the proposal. Now below this line you reject the proposal and above this line you accept the proposal. So basically the indifference line, which is constituted by those set of coordinates at which net present worth is 0, divides the xy plane in two regions. One is called acceptance zone, another one is called rejection zone. And on the line itself you are indifferent. That means you are neither for the proposal nor against the proposal. So, that is what is known as indifference line. So, this type of diagram you try to plot it for the problem which we started with in today's lecture, in which you were given acquisition cost of asset as 500,000, incomings rupees 100,000 for next 10 years, outgoings rupees 5,000 every year for next 10 years, salvage value of 50,000, interest rate of 12%. So, for this particular problem you try to do both sets of representation, first one family of curves approach and second one isoquants. So, this is slightly complicated than our previous example, in which we considered change in the variable one at a time. These two curves, one family of curve and second isoquants, are used frequently to show the changes in two variables at a time. Now, the third and the last one in sensitivity analysis under single variable is known as scenario analysis. I will just introduce you to this particular concept and I will work out an example in the next class. Basically, in sensitivity analysis involving more than two alternatives, we try to estimate the pessimistic value, the optimistic value and the most likely value for all the variables, and then we conduct scenario analysis. That means, what happens if all my variable values are going for a pessimistic value? What happens if all my variable values are taking an optimistic values, and what happens if all my variable values are taking a most likely values? So, in the next class I will take one example through which I will explain you how to perform scenario analysis, what are the advantages of scenario analysis, what are the limitations of scenario analysis. And in next class also we will take those sensitivity analysis in which we are given more than one alternative. In today's lecture we have concentrated only on situations in which single alternative is given. In next class we will take it up cases where more than one alternative is given. So, at this point I would like to end this particular lecture and I will invite if you have got any doubts or queries. Thank you. Yes, technology class, you have any doubt? Which one? Slides you want? Okay, I will send you tonight, no problem.
And my question is?
Yes.
Yesterday's first example.
Today's lecture, third example.
No, yesterday's first example.
Yesterday's lecture, let me see. What was the example, third example?
No, first example.
First example. You are referring to this? Please look at this slide.
Yes.
Okay, what is your doubt?
My question is that the existing equipment can be traded in today at rupees 6,000.
Hmm.
And we assumed the 600 credit value as a negative value in the cash flow diagram.
Okay.
I understood the 600 value, the 6,000 is together with the salvage value, it is my capital recovery, as I think. We assumed it as negative value. Why the reason?
I will tell you. If you remember in yesterday's class, I had told you that replacement analysis is performed from a third party angle. You remember it?
Yeah, yeah.
So, for a third party, it is as good as buying this old equipment at rupees 6,000. So, it is a cost for him. So, it will be shown in negative side.
What about the salvage value?
And salvage value will be in positive side. Salvage value will be in positive side. Why? For a third party, he is buying this equipment at 6,000 and he is hopeful that he will sell this equipment for 2,000 at the end of year 6.
Okay.
Clear?
And the other, yeah, it's clear now. And the other is the equipment was purchased 4 years before.
Yes. So we are not concerned about that. That is what is known as sunk cost. 22,000 minus 6,000, that is equal to 16,000, is the sunk cost. Third party will not be interested in knowing at what price you purchased the equipment 4 years ago or 3 years ago. He is interested in knowing at what price you will be able to get this equipment today.
Okay. But there is operation cost in that past 4 years. What if you consider that operation cost?
Operation cost is 7,000 per year. So that is the cost for third party.
Okay. We started considering from time 0 for both.
Yes, exactly.
Machine for. So what if you consider for the last 4 years for the first equipment?
We are not concerned about that. That is why always keep third party view in mind. Don't think that it is your equipment. Think that you are doing this analysis as a third party. You are not biased.
Okay.
So if you have third party in mind, you will never make mistake.
Okay.
Any other doubt?
Thank you. Clear now.
Thank you and good night.